Hello guys, this is Technical Avant-Garde. Welcome all of you in the PCB Designing Webinar series in the second session. We will be doing some interesting stuff today. So I discussed a schematic yesterday on water level indicator. I think it's the time to begin the schematic part. I'll show you that schematic first. Yeah. This is the schematic. We will start designing from today. I hope you all have installed KiCAD, which I had told you yesterday to install. So I had installed in my system. So it's up to you if you want to do with me or if you want this session to be recorded as it is already doing so. I will provide you the recording of this session. So let's start. So this is, I hope you all are able to see the KiCAD window. Yeah. So from this file, new project, then you have to set the location. I am saving the location somewhere in the libraries, like you can say in the document. So I am saving the water level indicator. Save. Can anyone tell me if he or she can able to see my KiCAD window on the chat? Just write yes or no. Okay. Thank you. So yeah, there are three extensions, that is .pro, uh, .pro, .sch, and the other is .KiCAD_PCB. I should erase this. Yeah, there are three extensions shown in this window of KiCAD. This .sch. So this project, this .pro means this is the project folder. Like you had named the project as the water level indicator. So this .pro is the project folder which contain all the necessary files you want to have in your project. That is your schematic, your design, PCB layout, your netlist, your Gerber file. All these things we will discuss in the further sections. So this is .pro means the project file or just the project. .sch means the schematic file. This is the main and the necessary file in which you will make the schematic which I had shown of the water level indicator. So this is the extension .sch. Water level indicator.sch means you will make the schematic in this file, and .KiCAD is .KiCAD_PCB is the design layout. Like you will design the layout, like you will design the PCB of the water level indicator in this file, and all these files .KiCAD_PCB and .sch Both these files are automatically saved in the .pro extension file, which is the project file of your project. Yeah. So I'll tell you something about, yeah, this is your schematic layout editor. The first one is your schematic layout editor. Again, this is the same thing, which is the .hc extension, schematic layout editor. The next one, this one is your, yeah, this one is your symbol editor. At the as the name shown written below, this is symbol editor. If you want to make your own symbol, like there are some symbols which are not available in this built-in software. This is the build. This is your built-in software. You have installed this software which had automatically installed some symbols and some footprints. If uh, those built-in symbols don't have your design symbol or the symbol which you want to design, then you can design using this tool. Like, yeah, this is where you will design your own IC or your own symbol if you want to design. So rather, there are many such ICs available. So there is no need to need to use this symbol editor. If you want or if there is a new IC come into the market and there is no symbol and footprint for that, then you can design. So this is the PCB layout editor. This is the same as this .KiCAD underscore PCB, where you will design your PCB, and this is again the footprint. This if you make your own symbol using this symbol editor, then for simultaneously for the same symbol you will design your footprint. This is the Gerber file, Gerber viewer or Gerber generator file. This is the file which you can in which you can see your PCB in a 3D mode or in a layer by layer sections. Like if you have your 4-layered PCB, then you can separate those layers by creating the Gerber file. And this is the you will not send uh, not the .pro, not the .hch, or not the .keycat underscore PCB to the manufacturer. You will always have to send the Gerber file to the manufacturer. If you want to get manufactured your PCB, that then they will ask where is your Gerber file. Then you will have to generate your Gerber file, and there is one more file named CPL, which is the parts placement file, where like it will tell you what at what exact location your parts are placed, your components are placed on the PCB. So this is the Gerber file which you will send to the vendor or the manufacturer who will design your PCB. And this is the PCB calculator. This is a very interesting thing and the most important thing in designing the layout. I think this must be discussed before designing the layout. I will give you some glimpse of PCB calculator. There is some specific trace width. Trace width means a correct connection between the two components. There will be a defined trace width across the current. If there is written by default written that 0.885495 ampere will give you 10 mils of trace width. So if you want to either you want your trace width, then you can change the trace width. Like I want 0.1 mil trace width, then it have the capability to allow 0.03 amps current. If that 0.1 mil trace allows the current of 0.04 amps, then that trace will not get too longer. It will burst after some few seconds or some few milliseconds or nanoseconds, because the capability of trace having a zero point 0.1 trace width, it will just allow 0.0314 amps of current. So there is a relation, direct proportional relation between the current and the trace width. We will discuss more on this when we will design the PCB. So now we will design the schematic. So double click on the water level indicator.sch file. It will open this EE schema. It is written that EE schema. EE schema means schematic for the project water level indicator. So I'll tell you something about this. This is again your footprint editor. This is your DRC. Remember, this DRC is the again the most important thing. DRC is the design rule check, or you can also say this is your electrical rule check. Means it will tell you the pads and the connections made in the schematic is equivalent to the pads and the traces made in the PCB. So it will uh, compare and match all both these things: connections with traces, connections in schematic with traces in PCB design, and pads in PCB design with terminals or terminals in the schematic. So it will give you that relation. Like if there is any mismatch or uncomparable connection or pad between the between these two files .sch and .keycat underscore PCB, so it will give you the error, and then you have to remove the error to have the finalized and successful Gerber file. This is the DRC, design rule check or electrical rule check. In KiCAD, it will say the electrical rule check sometimes, and it will sometimes say the DRC. In I think in Altium and Eagle, it will be known as the DRC, design rule check. This is the netlist. I told you, like, DRC will check the exact location and exact position of the component and the connection with the pads and the traces. And netlist is that text file or the netlist file which will contain all the positions of those components and the traces. This is the BOM file. BOM file means the like I had discussed in the last session also. BOM means bill of material. You will have a list of all the materials you had used in the schematic of your project. So I think it's time to start. Like click. This is the place symbol uh, denotion, like icon. So you have to click on this. I'm just synchronizing both the windows, like the schematic window and the KiCAD window. The main and the professional thing to do is, like, you have the schematic in your hand in the A4 size sheet. Like it is not possible to do. So I made this thing. Yeah, this is the schematic of the water level indicator, which we will design on this. So I will start with this buzzer, then BC547. I think everybody knows BC547 is a 3-terminal transistor, and these are the resistors of 220 ohm. This is the LEDs, And again, these are the resistors, and this is a 9-volt battery. So click on this. Click on place symbol and then click on this white window. I click on this and I will search buzzer. Like it is written that buzzer comma polarized. So I will choose this buzzer and place here. There are some shortcut keys to move. I'll tell you that thing also. Yeah, so these are the shortcuts. If you will place your mouse cursor on that component and click on M, then that component will start moving. And if you place your mouse component on the mouse cursor on your component and then press R, the component will rotate in one direction. And if you place your mouse cursor on your component and then click del, it will delete that selected component. And again, if you will place your mouse on the component and press C, then it will make a copy of that component. So these are the major shortcut keys which we will be using today. Yeah. And if you have a scroller in your mouse, then you can scroll to zoom in or zoom out. So I have a buzzer, then I will select the PC, again select the place symbol and click on this white screen and select BC547. Now I have to move this buzzer. I had placed cursor, my mouse cursor, this plus sign is the mouse cursor in the KiCAD CAD software. So I'd place this mouse cursor on this buzzer and press M. Now is it start moving. It start moving where you want to place, then just get to that location and press your mouse left key. I place this. Now I want to rotate because I want both the terminals in the downward direction. So I placed my mouse cursor on this component and press R. It will start rotating in the clockwise direction. Then I have to press 2 more times to get those terminals in the downward direction. Now it's the exact location which I want to place and exact position and orientation where I want to put this buzzer. Now I want to place this BC547 transistor. Now again I will put my mouse cursor on this symbol and press M. Now I think this is the right position. Yeah, I'll place the mouse in this position, and now I want to make the copy of this BC547. There are two things to get import your transistor. One thing is this, then you will again place this, press on the place symbol and click, and then find BC547, then click OK. Then again the component will get into this file. But the another thing is, then you can copy this component. Again, I will place my mouse cursor on this component and press C. Yeah. Now there are 2 copies of this BC54. Now I want 4 copies. So I will press C one more time. and one more time. So now these are the required BC547 or the transistor which we for which we want to make this schematic. Now I want this R3 220 ohms resistor. So again I will press this place symbol, click on this white board, and then just press R. This R represents a resistor. This is the resistor, and I will then click OK. Again, this resistor, I want this resistor in the horizontal way, so I will again press R. Now this is the exact position and the orientation I want to put this resistor R. So now I want 3 copies. Press C and move this resistor. Again press C, then move this resistor. Now this part is complete. Now I want 3 more resistors in the base terminal of the uh, transistor. Now I will again place my cursor on this resistor and press C. Don't get amazed, I'll just scrolling my mouse to get zoom in and zoom out in this schematic. I will again press C to have this copy, then again, yeah. Now I have total 6 resistors in my schematic, and in this also there are total 6 resistors: R1, R2, R3, R4, R5, R6. So yeah, if you just want to see uh, if you just want to zoom in your all the components you had just played, then just click on this zoom to fit the schematic page. It will just zoom the area of the symbols you have, like zoomed in this way. Now it's time to put the diode in the form of, like, we want the LED. So again I will click on the place symbol, click on this white symbol, white screen, and just type LED. Like, as the LED is light emitting diode, then the arrows must be towards the outwards from the diode. I have to place this diode here. Then again, I will place my cursor on this diode, press C. Again, I will press C. Yeah. So I think we all the components are done. Now this 9-volt battery is left. Again, I will click on this place symbol, click on this white screen, type battery. Place this battery somewhere. Now we have all the components required for the schematic. Now we will do the connection. For connection, I will choose this place wire, this green colored symbol. Click on this place wire and start connecting the required connections. Just click on one terminal and go to the destination terminal. I have to move this battery, so I am moving this battery in this direction. until or unless this is the this green hole means the junction in the wire. Like there are two things, like you can see this and you can see this. This is the junction and this is the non-connected wire crossing. Like this wire is not connected to this wire, like horizontal wire is not connected to the vertical wire. In this is the T junction. Like all the wires coming to this green hole are connected to a single point. So until or unless you don't have this green symbol in the connection, then your connection is not completed yet. I have to connect to this, again connect to this and this. Now I have to make this blue dummy water tank. For this blue dummy water tank, I'll make this using this tool, which means place graphic lines or polygon. You can make any type of shape using this tool. I'll make the bucket, longer bucket will be better. Yeah, just press escape or right click to cancel or end drawing. After clicking on the end drawing, the last pointed where you clicked your mouse will be the last connection or the last point of that polygon. This is something amazing water tank. Now I will place these A, B, C, D levels of the water. These are the levels. A, B, C, D is the levels of the water in from uh, like from full to like sorry, like from half to like empty from full. Like A is the empty and D is the full. Just drop the wire here. Like we don't want to connect uh, the another terminal of this wire because as you all know, water is the electrically conductive material. So this open wire will conduct when it comes in contact with this, when water will come in this contact. This is the last wire. Yeah, now I have to write this A B C D. For this I will use the place text symbol. It will ask the text size. What will be your text size? I will write A, and if you want to change the text size, I will give the 2 mm. Like if you want to choose some different style like normal, italic, bold and italic. To make something interesting, I will choose bold, italic and press OK. And this again, press B, OK. Again same for C, again for D. Now our schematic is done. Yeah, your schematic is done. The most important thing is still left. You can see BC 220 ohm resistor. We had not mentioned any value of the resistor. To edit this value, just place your cursor on this R button, R symbol, not on R question mark, but on R, and press E. Yeah, for placing your mouse cursor on the symbol or the value and press E. It will edit the properties of the symbol. Yeah, I'll place the cursor on R and press E. Now it will asking you to edit the value of this symbol. Now I want the value 220. Now I'll press 220. Again for this 220. Again for this 220. I'm just placing my cursor on the R and pressing the value E, pressing the button, the keyboard button E. Now you all are aware that there are question marks in this schematic, and there are like buzz one, it is written Q4, Q3, Q2. This thing I'll tell you tomorrow how to do this. The process is known as annotation. Like you will annotate your schematic, and it will automatically give every symbol a number, like a possible number. It will possible in either you want to do in vertical direction, or you will if you want to do in horizontal direction, then in both direction you can do so. But for this you have to wait for tomorrow's session. So yeah, this is for today. Now for this I'll just save my this sheet, this schematic sheet, and just click on save, or you can also press Ctrl plus S, Ctrl plus S. I'll write this to on this. Yeah, Ctrl plus S to save the schematic. Yeah, like if you will place your mouse cursor on any like on the text or on the component and press M, then that text or component will start moving. If you will press R, that it will start rotating in the clockwise direction. Then if you will press delete, then that component or text get deleted. Then if you will place if you will click C, then that text or component get copied. And if you want to edit the properties of the component, or you want to edit any field value or any component value, then you will press E. And if you want to if you are done with your schematic and want to save, then either you will click on that save button, or just press Ctrl plus S.